So I'm keeping a record of this particular section, that's intersection of a line with a circle. Okay. Let us consider the line as y is equals to mx plus lambda and the circle as x square plus y square plus 2gx plus 2fy plus c is equal to 0. So the line being considered as a non-vertical line, that is where we are considering it as y is equals to mx plus lambda. Only the vertical lines cannot be represented in this variation. And we are considering our circle in standard general form. Okay. Now, if we try to have the intersection of the line with a circle, there are three variations possible, and how we can get conclusion of each variation. So as we are looking for intersection points, so that means it will be simultaneous solution of both. So we can associate the two equations. Now, as soon as we have associated the two equations, the way of association will be easier if we get to any one variable in terms of the other from the equation of line. Like over here, we already have y been described as mx plus lambda. So in the equation of circle, if I replace y with mx plus lambda, that will give us association of both the equation. And as soon as we go for this substitution, the equation of the circle reduces to a quadratic in a single variable. Like over here, we have got 1 plus m square into x square plus 2 into m lambda plus g plus mf whole into x plus lambda square plus 2f lambda plus c is equals to 0. So whatever constant coefficients are appearing, we need not look into that. The basic matter of the fact, once we go through this substitution and through association of the equation, we are getting reduced to a single variable quadratic. Let us consider this equation has discriminant capital D. Now, if we have capital D, that is the discriminant positive, then we will get two real and distinct roots of the equation, and they will be the abscissas for the common points. Corresponding ordinates we can found by substituting this abscissas on the relation y is equals to mx plus lambda. So after getting reduced to a single variable quadratic, if we are sure that our discriminant is positive, so that means the line we have associated with the circle, they are going to have 2 points in common. And the abscissas of those common points can be found as roots of this found quadratic and corresponding ordinates from the equation of the line as they are common to both. Okay. As such, in that case, we can confirm that the line will act as a secant for the circle, or equivalently, we can conclude the line will generate a chord with the circle because they do have two distinct points in common. Now, if discriminant is 0, then the quadratic will have two real but identical roots, and hence this identical roots will be abscissa for the only common point. Corresponding ordinate can again be found from the 1 degree relation, that ordinate will be m times abscissa plus lambda. Whereas this time we can identify the line as a tangent to the circle. Is the idea okay so far?
Yes, sir.
But if we get discriminant less than 0, then algebraically we are not getting any real root for the equation, and hence no common point geometrically. That leads us to the conclusion that the line will not come into contact with this circle. Now, on the basis of this discussion, let us try to identify a solution for this question. It is asking us for the extremities of the chord of x square plus y square minus 6x plus 8y is equals to 0, appearing along x minus y is equals to 2. can you all follow that how to go for the solution of this question? So can anyone answer me what will be the initial approach to this solution?
স্যার সেকেন্ড ইকুয়েশনটা থেকে x ইকুয়ালস টু 2y পাবো, সেটা 2 প্লাস y পাবো, সেটাকে সাবস্টিটিউট করতে হবে ফার্স্ট এরটায়, মানে সার্কেলের ইকুয়েশনটা।
Okay. So either we can go for substitution of x is equals to y plus 2, or we can go for y is equals to x minus 2. So we can proceed through any one of this substitution. Over here, I have gone for y is equals to x minus 2. That has led us to this quadratic in x square minus x minus 6 equals to 0, with solutions x is equals to 3 or minus 2. If values of x are appearing as 3 or minus 2, corresponding ordinates can be found from x minus y is equals to 2. So required extremities of the ordinates will be 3, 1, as the ordinate always supposed to be 2 units less than the abscissa. So when abscissa is 3, ordinate has to be 2. When abscissa is minus 2, ordinate has to be minus 4.
This x minus y.
Idea?
Yes.
Yes. X minus y is 2, so ordinate will always be 2 units less than the abscissa. So as soon as we get the roots from the quadratic as abscissas of common point, corresponding ordinates can be marked as 2 units less than abscissa. Okay. Now the next idea, positioning of a line with respect to a circle. So you can identify with respect to a circle, a straight line can appear in this 3 variation. Okay, and we always have a choice to go by number of common points of the considered line with the circle to identify its positioning, like we have done in the earlier section. If there are 2 points in common, like we are considering this variation, 2 points are common. So in that case, line will be generating a chord and will act as a secant. Or we can have only 1 point in common. In that case, line will act as a tangent. Or we might have no point in common. In that case, line is passing through outside. Whereas we can identify there is another parameter which can be confirmed about them apart from number of common points. Like if it is a chord, then the minimum distance from the center is some r1 less than the radius. When the line is a tangent, then the minimum distance is itself radius. And if it is not generating any point for common, so definitely the minimum distance from the center is more than radius. Okay, so that's why it's been written that apart from the number of common points decided by the association of the line and the circle as shown earlier, we can also decide the position of a line with respect to a circle by the distance of the line from the center of the circle. Over here, we know that r1 distance, which is less than radius, will take us to secant or a chord generating line. The perpendicular distance itself r will confirm the line to be tangent, and hence the distances when been found more than radius, we can confirm it's a line passing through outside, or the line does not come into contact with the circle. In any way, if we try to identify the condition of tangency, we can consider the distance of the line from the center same as the radius of the circle, or otherwise we can also go by the earlier association, where the association will lead us to a quadratic with discriminant 0. So any one such approach will work. Now we have considered that when we consider a circle, it is in the simplest form. If it's centered at origin and radius is r, then the circle appears to us in the simplest form. That's x square plus y square is equals to r square. And we know how to address the parallel shift of coordinate axis so that origin parallelly shift to alpha comma beta. Let us have a look in that particular section. Like if we think of parallel shifting of coordinate axis through this form, it was supposed to be origin, and say at this moment we are considering this alpha comma beta as new origin. So what will happen? Now through this point, the horizontal line passes is y minus beta is equals to 0, which was earlier supposed to be y is equals to 0. The vertical reference line through alpha comma beta is now appearing as x minus alpha is equals to 0, which was earlier x is equals to 0. So due to parallel shift, equations of any curve must be replacing x with x minus alpha and y with y minus beta, right? Whereas, what kind of change we are going to have in coordinate of any point? Like if we consider this circle with center at origin and radius r. So rightmost point was r comma 0, topmost point was 0 comma r, and any general point as h comma k. Now let us consider this circle whose center is alpha comma beta and radius is still r. The rightmost point will be now alpha plus r comma beta, that is r plus alpha comma 0 plus beta, and the topmost point is 0 plus alpha comma r plus beta. And in general, we can identify any general coordinate which was supposed to be h comma k now should appear as h plus alpha comma k plus beta. So if we shift origin parallelly to the point alpha comma beta, due to that any point which was earlier gettable as h comma k, now that will appear at h plus alpha comma k plus beta. So as far as the new coordinates are concerned, we will add alpha to abscissa part and we will add beta to ordinate part, irrespective of the fact whether alpha or beta is positive or negative. Okay? So that's what we get through parallel shift. And accordingly, we can identify definitely if we get to properties for this circle, which is in simplest form, x square plus y square is equals to r square, it will be lesser algebraic calculation. Okay? But once we get to the reference, we can change the equation and coordinates for the other form of circles simply by using this rule, that while changing equation, we will be replacing x with x minus alpha, y with y minus beta, and while changing coordinates, we will replace h comma k with h plus alpha comma k plus beta, right? So keeping this idea in mind, we have gone for generating the equation of tangent or identifying the condition of tangency for a circle. So what we targeted is, let us consider the circle in simplest form and the line with slope in. Okay, so we have taken the line as y is equals to mx plus lambda. So definitely it is a line with slope in. Now, do you know that for a particular slope, how many tangents for a circle is gettable? If we think of a circle and consider any tangent of a circle, can I have any other tangent of the circle in the same direction, or it will be unique? Will it be unique?
So in the same direction, it will be unique.
I'm asking for the direction, not the line. Like in this diagram, you can identify this pink line is a tangent.
Yes, sir.
Can I have any other tangent of the circle going in the same direction, or it
Yes,
will
sir.
be the only line of this direction?
There can be another one in its opposite.
Can be another one. Like from the diametric other end of this point, if I get to the diametrically other extreme and draw a tangent, It will also go in same direction that we know by circular geometry. Let us get to know whether it is gettable through coordinate or not, whether we can establish this fact or not. So what we have done, we have firstly gone by the approach one, that is the association. So the association has given us x square plus mx plus lambda whole square is equals to r square. That is, on opening up, it's 1 plus m square into x square plus 2m lambda into x plus lambda square minus r square is equals to 0. Now for tangency, this associated quadratic must have discriminant 0. That led us to the condition that lambda should be, or lambda square should be r square into 1 plus m square, or lambda itself coming up with two possibilities, plus or minus r into root over 1 plus m square. So the dual condition for lambda confirms with respect to same slope m, we can have two possible tangents, one with constant term r into root over 1 plus m square, and the other one with negative of r into root over 1 plus m square. Is that okay? As such, we can also go by approach 2. We can identify the distance of the line y is equals to mx plus lambda from the center, which is 0, 0. And if we equate that with r, it will definitely be confirmed as tangent. Now from 0, 0, distance of the line y minus mx minus lambda is equals to 0. That will be mod of lambda by root over 1 plus m square. For tangency purpose, this distance must be r. So again giving us the same conditioning that lambda is equals to plus or minus r into root over 1 plus m square. Now you can identify as the circle was in simplest form. So both the approaches are more or less equivalent. But if we do have greater number of terms in the equation of the circle, still the second process will stay this much. It will never be that lengthy. But if we have more terms in the circle, the first approach can be quite lengthy in terms of associated equation, and from there equating discriminant with 0. Okay, so you can select your approach as per your comfortability. As such, approach 2 is more apt when the circular equation is not in simplest form. Okay, is it okay with everyone? This part clear? Anyone with any confusion? So on the basis of this discussion, we can confirm for any given slope m, the two lines y is equals to mx plus or minus r into root over 1 plus m square must be a tangent to x square plus y square is equals to r square. So parallel tangents exist for circle. Okay. So with respect to any given slope, we can always have two tangents for a circle having that particular value as slope. Okay. Parallel tangents exist for circle. Moreover, as soon as we are decided with that simplest form of circle to have equation of tangent when the slope is given to be m, and we have found the equation as y is equals to mx plus or minus r into root over 1 plus m square. So if we think of this circle, x minus alpha whole square plus y minus beta whole square is equals to r square. It's a parallel shift of origin to alpha comma beta, and hence the new equation of tangent with slope m can be found by replacing y with y minus beta and replacing x as x minus alpha. You can identify from this equation, if I replace y with y minus beta and x with x minus alpha, this x with x minus alpha, this is the changed equation we are getting. Is that okay? So without going for hectic algebraic calculation for this linear format of representation of circle, we have done the algebraic calculation part for the simplest form of circle. And once we have the result, then we are generalizing through parallel shift. For circle rotation not to be considered, like if a circle been rotated about its center, can we pursue any kind of change in the circular attributes or location? If I ensure that a circle is rotating about its center, okay, will there be any change in the position of the points? Or will there be any change in the shape and size for the circle? Yes or no? Okay. So that is why rotations for circle not to be addressed. All that we need to identify is the parallel shift. So on a similar note, when we consider circle in its standard general form, then to have its equation of tangent with slope m, we will simply consider now the center been parallelly shifted to minus g comma minus f, and the radius of reference is now root over g square plus h square minus 3, right? So the new equation we can get by replacing y with y plus f and x with x plus g, and also replaced the radius measurement by root over g square plus f square minus 3. So is that okay? So without any hectic calculation, we can derive that because we have done the algebraic calculation part for simplest form of circle, and now for the other formats, the lone possibilities we are considering is parallel shift.